All right, today we're looking at lesson 8-1, reducing radicals and rationalizing. So let's go ahead and get that learning intention down. I will learn how to simplify radicals or square roots and rationalize. So basically the term radical is just a fancy name for square root. So you'll be hearing me say radical quite a bit, but it's really square root. And today, for this lesson, we're not going to be using TI-30s. I know while you're watching this video, we can't really see what you're using. However, you must show every step. And so even if you're using the TI-30, you're going to have to show every step, okay? Let's start off by getting our perfect squares. You should have this chart on your paper of perfect squares. And a square is just a number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so forth, all the way down. So if you need to pause the video, go ahead and get these down. Okay, so looking at these, we're going to be finding square roots. If we look at the square root of 49, we can see that we can do that, and it comes out neatly. It comes out to 7. So the square root of 49 is 7, or it's like saying 7 times 7 is 49. Looking at the square root of 25, we can also do the same. What times what is 25? We can also look at our chart. It also comes out neatly to 5. Looking at 144, we can also see it comes out neatly to 12. Okay, now we're going to take it another step further. I have 2 times the square root of 36. Notice 2 is not inside of this radical. And remember, a radical is another word for square root, and this is a square root sign. 2 is not on the inside of it, it's on the outside. So I'm going to bring it down for the ride, and I'm going to figure the square root of 36. The square root of 36 is 6. So my answer is simply 2 times 6 is 12. Okay, the square root of 0 is 0. And here we go, we have a -5 on the outside of the radical, so it's going to come down for the ride. And the square root of 100, we can easily see, is 10. So we times that by 10, we get a -50. Now let's look at number 7. I have a square root of 8, and if you were to put the square root of 8 in your calculator, you'll see that you're going to come out with a nasty decimal. You can see that 8 is not a perfect square. It cannot be square rooted, and we don't want decimals today. So what we're going to do is simplify this, and we need to first find a perfect square that goes into it. So we need to find a number that goes into it, and it has to be a perfect square. So looking at my chart, I know that 4 goes into 8, and 4 is a perfect square. So 4 goes into 8 2 times. Okay, and now I'm going to see if I can simplify this a step further, and I can. I can take the square root of 4 and get 2. And there's nothing else I can do with the square root of 2. I can't square root it. It doesn't come out good. It can't be simplified anymore. So my answer is simply 2 times the square root of 2. So let's look at the square root of 27. Before you do anything, you need to check and see if it can be square rooted neatly. And once we can see it cannot, we need to find a perfect square, the largest perfect square that can go into it. Okay, and when I'm looking at these, I do see that 9 is a perfect square. 9 can also go into it. So I know that 9 goes into 27 3 times. And once again, I need to take this another step further. The square root of 9 is 3, and my radical of 3 cannot be reduced anymore, so this is my answer. Okay, I'm going to look at the square root of 600 now. We need to look and see, can the square root of 600 be found neatly? So if you took your calculator, and if you put the square root of 600 in it, you're going to find a decimal. It's not going to come out neat. So we need to simplify it by finding the largest square that can go into it. Looking at my chart, I'm looking at these numbers. These do not go into 600 until I get to here. 100 goes into it, and 100 goes into it 6 times. Okay, and now I need to check and see, can I simplify these down any further? The square root of 100 is 10, and the square root of 6 cannot be simplified any further, so this is my answer. Okay, let's look at number 10. And on number 10, I have the square root of 72. Get in a habit of always asking yourself, is this going to come out pretty? So take the square root of 72 in your calculator, and you're going to get a nasty decimal. Or you can come over here, and if you see 72, then you know it'll work, and it's not over here. Okay, so we need to find the largest perfect square that can go into 72. So sometimes it's trial and error, but I like to start with big numbers first. Okay, I know that 64 is too big, these are too big. Once we start getting down to here, you can start trying them to see. Does 49 go into 72? Does 36 go into 72? And the way you would check it in your calculator is 72 divided by 36. 36 is a perfect square, and it does go into 72 2 times. Okay, so now I can reduce this more. The square reduces more. The square root of 36 is 6. And radical 2 cannot come down anymore. That's as far as it can be simplified. So let's look at number 11. Once again, this negative 3 is on the outside. It's going to come down for the right for now. And then we're going to ask ourselves, can 125 be square rooted evenly? So first of all, it's not over here on my chart. And if I put it in my calculator, I get a decimal. So I need to find a perfect square that goes into 125, the largest one. And right here, I can see 25 goes into 125 5 times. Okay, so now I have a little bit more simplifying I have to do. My negative 3 still coming down for the ride. The square root of 25 is 5, so these are times. If this is on the outside of it, it's this times this. So this is still this times this. And I cannot reduce the square root of 5 anymore. Okay, still not done simplifying. Negative 3 times 5 is negative 15. And I'm just going to go ahead and bring down that radical 5. And this is my answer. All right, looking at number 12, I have 8 times the square root of 63. Once again, the 8 is on the outside of the radical. I will bring it down for the ride. And I need to find a perfect square that goes into 63. Looking over here, I can start trying to find some numbers. I want the largest one. And if I push in my calculator, and the way I would do it is 63 divided by, and I start trying perfect squares. I will eventually get to 9, and I find out that 9 goes into 63 7 times. Okay, so once again, my 8 comes down for the right again. The square root of 9 is 3, and I cannot reduce the radical 7 anymore. Okay, so 8 times 3 is 24, and then radical 7 just comes down. Okay, let's look at number 13. When you have them like this, once again, 4 is on the outside, and we need to see, can either of these be square rooted? Okay, they cannot. So what we need to do is, because they are the same, they both have square roots over them, kind of like terms. When we talk about like terms, it's kind of like that. But because they both have radicals, we can times them together. So 5 times 12 is 60. So I now have 4 times the square root of 60, and now I'm going to work with this problem. So once again, my 4 is still on the outside, so it comes down for the ride. And now I need to find the largest square that can go into 60. So looking at my chart and using my calculator, I'm going to start finding things that can go into 60. These are still too big. Can 25 go into 60? I know that it can't. If you need to try 16, you can put 60 divided by 16 in your calculator. You should see that you can't. And I finally find that 4 can 5 times. Okay? No, 15 times. I'm sorry. 4 times 15 is 60. So now I can simplify this a little bit more. The square root of 4 is 2. And I cannot square root 15, nor can I simplify it anymore. I can simplify 4 times 2, though, and it is 8. And I just bring this down, and this is my final answer. All right, let's look at number 14. Remember, the very first thing we're going to ask is, can either of these be square rooted evenly? Can 18? So I could either look at my chart, I don't see 18, or if I put a second square root in my calculator, 18 is going to be a decimal. Either way. So that cannot. Let's look at 36. Can it? 36 is on my chart. So 36 can actually be square rooted evenly. The square root of 36 is 6. This one could not, so I'm just going to bring him down. Now this is what I'm working with. And 6 is on the outside of my radical, so he comes down for the ride. And I want to see if I can simplify square root of 18 anymore. Okay, so is there a perfect square that goes into 18? Looking at my chart, I know 9 goes into 18, and it's also a perfect square. So I'm going to have the square root of 9 times the square root of 2. And once again, I can still simplify more, so my 6 comes down. The square root of 9 is 3 times the square root of 2. So my final answer is 6 times 3 is 18 times the square root of 2. All right, let's look at number 15. Now we're dealing with a numerator and a denominator. And the thing we need to know about fractions is we cannot have a radical in the denominator, okay? So I also notice, I'm just noticing some things. I don't have a radical in the numerator, and we'll kind of talk about that later. But so to get rid of this radical in the denominator, I'm going to times the numerator and the denominator by this radical, okay? And so 2 times radical 3 is just like this, 2 times radical 3. And 3 times radical 3, it's just going to stay 3. So anytime you take a radical with a number times itself with a radical, the radical sign goes away, and it's just 3. And I'll show you why. So if I took radical 3 times radical 3 and got radical 9, and then if I square rooted 9, I get 3. So, and this is how we're getting rid of the radical and just turning it into 3. This cannot be simplified down anymore, so that is my answer. All right, number 16. So now I have a radical in the numerator and a radical in the denominator. So the first thing I'm going to look at is, can they be divided evenly? Can I take 4 and divide by 2 and it come out evenly? And I can do that because they both are radicals. So 4 divided by 2 is just 2, and they are both radicals, so my answer is a radical. So my answer is radical 2. All right, let's look at 17. Once again, I have a radical in the denominator. I do not want that. And I look at the above. So these I divided and I was able to. I can't do that here. 12 is not a radical. Yes, I can take 12 divided by 6, but in this problem I cannot because it's not a radical. They have to be the same. They are not. So in this instance, I'm going to get rid of that bottom radical by taking both the numerator and denominator times the radical. So this is going to give me 12 radical 6 over, and remember the radicals just go away and it gives me 6. Now I'm going to look at this. Can it be simplified down anymore? And it can't, because 12 divided by 6 is 2, and then I'm left with 2 radical 6. Okay? And let's look at 18. We have this giant radical sign, and that's nothing to worry about. It just means that 9 is a radical and 3 is a radical. So it's kind of like writing this. It's the same thing as that. Okay? So when, just like this one, they were both radicals, and I could take 4 divided by 2, and it came out even. This is the same thing. They are both radicals, and I can take 9 divided by 3, and I get 3. And this is my answer. Okay, so let's look at 19. All right, I have 2 times radical 3 over radical 2. So I'm going to look over here. Nothing can be divided equally. So once again, I need to get rid of the radical in the bottom by timesing the top and the bottom by a radical. Okay, so I have my 2 out here. It's on the outside. And 3 times 2 gives me radical 6. And then remember what we said, a radical of a number times itself. The radical just goes away, and we end up with this. Okay? Now we need to look and say, can this be simplified down anymore? And it can't. If I have 2 over 2, these can just cancel, and I end up with radical 6. And the reason why these are canceled, for example, if I had 3a to the third over 3a, 3 over 3, these are the same. These can be canceled, and these will leave me with a to the third over a. Well, this is kind of the same thing. These 2's are the same, and they can cancel out, leaving me with radical 6. Okay, so over here, I have 5 radical 2, 5 times radical 2 over 3 times radical 5. Nothing can be divided by equally yet, so I need to get rid of that radical in the denominator by taking the numerator and denominator by that radical. So this leaves me with 5 times 2 times 5 is 10 over, and once again the 3 will come over, but these 5, the radical sign goes away, and it's just 5. And I'm taking 3 times 5 because that's what this 3 is on the outside, 3 times radical 5. So when these go away, it's 3 times 5. So let's simplify this down a little bit. I have 5 radical 10 over 3 times 5 is 15. So I need to look, can this be simplified down anymore? And it can, because 5 goes into 15 one time. So if I know 5 goes into 15 one time, that leaves me with radical 10. And do I really need to write this 1 in front of the 10, radical 10? I do not. And then 5 goes into 15 3 times. So this is what I'm left with my answer. Radical 10 over radical 3. All right, number 21. Just going to move this guy here out of the way. Okay, so once again, nothing can be divided equally. I do have radicals. I want to get rid of the radical in the denominator. So I'm going to take the top and the bottom times radical 5. Radical 7 times radical 5 gives me radical 35. And then my 2 comes down, and then what happens with these radicals? They go away, and that gives me 2 times 5. So I am going to simplify this down a little bit more. I have radical 35, and we need to say, is there a perfect square or anything we can put in a 35? And there is not, and then 2 times 5 is 10, so this is my answer. All right, please let me know if you have any questions, and thank you.